My dear students, today we are going to start our discussion in chapter 2 in our syllabus, which is chemical analysis. We are going to discuss the importance of chemical analysis in our life, and we are going to discuss its benefit in different fields. Also, we are going to discuss the types of chemical analysis, which are qualitative analysis and quantitative analysis. We are going to discuss these concepts in details, and today we are going to start our discussion in qualitative analysis, and we are going to discuss the detection of anion radicals as we are going to start our discussion. So let us start. Chemical analysis. Chemical analysis can be used in different fields. In medicine, the diagnosis of disease depends on the chemical analysis to estimate the percentage of sugar, albumin, uremia, and cholesterol, and others. Also, estimate the amount of the effective substance in medicine. Also, in agriculture, improve the properties of the soil in terms of acidity and basicity and the agreement of the soil in the agriculture crops. Also, determination of the type and proportion of the elements that found in the soil to decide the use of these suitable fertilizers. In industry, the chemical analysis helps in determination of the concentration and the ratio of raw materials and products that verify the standard specification. In environment, determination of the harmful environmental pollutants in water and food. Also, determination of pollutant materials in air, such as carbon monoxide gas, or sulfur dioxide gas, or nitrogen oxide gases. What do you mean by the analytical chemistry or chemical analysis? This concept means that it is the branch of the chemistry that deals with the methods and instruments used for both qualitative identification and quantitative determination of the substance. Now we are going to discuss these concepts, qualitative and quantitative determination. So we are going to discuss first the types of analysis. Qualitative analysis, it is the identification of the constituents of the substance, if it is pure or mixture. While quantitative analysis, it is the determination of the ratio or the percentage of the constituents of the sample. Today, my dear students, we are going to discuss the qualitative analysis. The pure substance can be identified through its physical properties as melting point. My dear students, the pure substance like iron, like aluminium, like any element, if you want to know it is pure or not, we have to discuss its physical properties like melting point, boiling point, density. So if someone gives you a piece of gold, how can you notice gold? From its density. So the gold density has fixed value. If the piece of metal that given to you has not the density of gold, so it is not pure gold. So we can know the pure substance through its physical properties like density, the boiling point, melting point, and etc. Now, the identification of the constituents of the mixture occurs after separation of the constituents, then detecting them through chemical methods. The types of qualitative analysis. Analysis of organic compounds, and we are going to discuss this in details in chapter 5, which is the identification of the organic compounds through detecting the elements constituting this compound and its functional group. While the analysis of inorganic compounds that we are going to discuss in this chapter in details, which is the identification of the cations, which are positive ions, and anions, which are negative ions that forming the compound. The analysis of inorganic compounds depends on the formation of the salts. How can we know the salt can be formed to detect its positive ion, which is cation, and its negative ion, which is anion? The salt is formed from neutralization reaction between acids and bases. Also, salts are produced by the reaction of acids with metals. My dear student, notice that the acids, as hydrochloric acid, its chemical formula HCl, sulfuric acid, its chemical formula H2SO4, nitric acid, its chemical formula HNO3. Bases, which are metal oxides, or metal hydroxides, or metal carbonates, or metal bicarbonates. Salts, such as sodium chloride, copper sulfate. Each salt consists of two parts, positive ion and negative ion. The positive ion comes from the base, we call it basic radical, and the negative ion comes from the acid, we call it acidic radical. So, positive ion for sodium and the copper comes from the base, so they are called basic radicals or cations. And negative ion as chloride ion and sulfate anion, they are coming from acids, so we call them acidic radicals or anion. This episode, we are going to discuss the detection of anions, which are acidic radicals. The identification of the anions is divided into three groups, depending on the reagent used. The acids can be classified according to their boiling point into more stable acids and less stable acids. According to this classification, we are going to detect the anions as we are going to make reaction between acid, which is more stable, with the salt of the acid, which is less stable, in order to release the less stable acid in form of gas to be detected. So, we classify the anions into three groups. We are going to discuss each group by an acid which is more stable than the acids of these ions which are going to detect, to release their less stable acid in form of gas that has suitable test. So, look at the following illustration. The anions of dilute hydrochloric acid. It includes the following anions: carbonate anion, bicarbonate anion, and sulfite anion. Be careful that when you are going to write the radicals, don't forget the writing of the charge above the radical. CO3 above it 2 negative charges, HCO3 above it 1 negative charge, SO3 above it 2 negative charges, which indicate their valency also. Carbonate radical has valency 2, bicarbonate radical has valency 1, sulfite radical has valency 2. Also, sulfide ion, that S has the negative 2, its valency is 2, and thiosulfate radical S2O3 that has negative 2 charge and valency 2, and the last one of the group that detected by dilute hydrochloric acid, which is nitrite, NO2 negative 1 has 1 valency equal 1. So we have confusion in this point. The hydrochloric acid is used to detect the above anions. As I told you, we have to say because the hydrochloric acid is more stable than the acids of these anions. So when it reacts with their salts, the products of the reaction is releasing their less stable acid in form of gas that can be detected by suitable test. The first radical we are going to discuss is carbonate anion. My dear students, during detection of anions, we classify them into 3 groups. The first and second group is to detect the anions that by more stable acid. In these detections, we have 2 types of tests, main test and confirmatory test. The main test is using the solid salt and add the acid over it, while the confirmatory test is using the salt solution and add substance that make reaction and precipitate with it, as we are going to discuss now in details. The main test for carbonate radical is using the unknown solid salt with dilute hydrochloric acid. Here, the observation effervescence occurs due to production or evolution of carbon dioxide gas, as the following animation show. As shown on the screen, we bring test tube and we put the carbonate salt in it. Then we add dilute hydrochloric acid as shown on the screen. Then the gas and effervescence produced, the gas obtained is here passed over clear lime water. Here the clear lime water as shown on the screen turns into turbid as the clear lime water becomes like the milk, or we can say milky, due to formation of calcium carbonate, which is insoluble in water. So as the equation proceeds on the screen, sodium carbonate plus hydrochloric acid. Remember, my dear student, the physical state, sodium carbonate is solid, so the subscript is S. Hydrochloric acid is dilute acid, so the subscript is aqueous. So it gives sodium chloride, aqueous solution, and the carbon dioxide gas and water is produced. Here, the detection of carbon dioxide gas, or the test for the produced gas, we found that the carbon dioxide gas turbids the clear lime water that we saw in the experiment animation that we showed from the test of the carbonate anion. Here, what happens when carbon dioxide gas passes for lime water, through lime water? Here, lime water is calcium hydroxide. When carbon dioxide reacts with it, it forms white precipitate of calcium carbonate that turns the lime water into turbid and water is produced. But what about on passing this carbon dioxide gas for a long time? The turbidity disappears. Why? Because the carbon dioxide that passed in excess reacts with the calcium carbonate and water, forming calcium bicarbonate, which is soluble in water. So the turbidity disappears. So the reaction here means that the insoluble calcium carbonate is converted into soluble calcium bicarbonate. So the turbidity disappears. Now we are going to discuss the confirmatory test. Here is the salt solution plus magnesium sulfate solution. What happens? Here white precipitate of magnesium carbonate is formed on cold, as the following animation show. Here, my dear student, on adding the magnesium sulfate solution on the salt solution, it gives white precipitate of magnesium carbonate. So we can know now the carbonate radical is present. As the equation proceeds for the reaction, sodium carbonate now it is salt solution, not solid salt like the main test, so its subscript is aqueous. plus magnesium sulfate, which is aqueous solution, it gives sodium sulfate aqueous solution and wide precipitate of magnesium carbonate. The produced precipitate here, which is magnesium carbonate, is soluble in dilute hydrochloric acid. So magnesium carbonate, if we add hydrochloric acid dilute over it, it turns into magnesium chloride. Magnesium chloride soluble in water, so the white precipitate disappears, and also carbon dioxide gas and water are produced. My dear students, notice that most of carbonates are insoluble in water except carbonates of sodium ion, potassium ion, ammonium ion, while all of them are soluble in acids. But all bicarbonate are soluble in water. Any metal bicarbonate soluble in water. My dear students, in this point we have some questions in the exam about choose questions. Now I told you all carbonate salts are insoluble in water. يعني كل الكربونات salts ما بتدوبش في المية، ولكن صوديوم كربونات، بوتاسيوم كربونات، ammonia carbonate soluble in water. So we can give in the exam differentiate between sodium carbonate and magnesium carbonate. The simple test for them is dissolving in water. Only sodium carbonate is soluble in water, while magnesium carbonate is insoluble in water. So we can use the solubility test for differentiate between types of carbonate, but only that contains sodium and potassium and ammonium and the other carbonate of different other metals. But all bicarbonates, we can't differentiate between them because all of bicarbonates are soluble in water. Now we are going to complete our discussion. Here we are going to detect the bicarbonate radical. The bicarbonate radical, which is the main test for discussion, is the use of unknown solid salt. لازم ناخد solid salt plus dilute hydrochloric acid. What do you observe? Also we observe effervescence and the production of carbon dioxide gas evolves. يعني هيحصل فوران وهيطلع برضو الكربون دايوكسيد جاز من الأنبوبة ونعمل له تيست باللاين موتر. As the following animation show. Here, my dear students, now dilute hydrochloric acid is added to sodium bicarbonate solid salt. The carbon dioxide evolves and turbid lime water. So, my dear students, now dilute hydrochloric acid cannot be used for differentiate between sodium carbonate and sodium bicarbonate. ليه؟ لأن في الحالتين بيعمل فوران وبيطلع كربون دايوكسيد جاز. يبقى in both cases carbon dioxide gas evolves and turbid lime water. So we cannot use dilute hydrochloric acid to differentiate between sodium carbonate and sodium bicarbonate. But we are going to use the confirmatory test. That we are going to use magnesium sulfate. احنا قلنا من شوية ان المغنيسيوم سلفيت react مع الصوديوم كربونات و give wide precipitate in cold of magnesium carbonate. What about the confirmatory test about using the magnesium sulfate with sodium bicarbonate? We are going to show in the following illustration. يبقى هنا يا ولاد الرياكشن between الصوديوم bicarbonate and hydrochloric acid also gives sodium chloride solution and carbon dioxide gas and water. So the test for the produced gas is using lime water. Here carbon dioxide gas reacts with lime water, which is calcium hydroxide, and gives calcium carbonate, which is wide precipitate. So turbid the lime water. Then if we pass the carbon dioxide for a long time, لو مخلينا الكربون دايوكسيد يمر لفترة أطول يبقى so it reacts with the precipitate of calcium carbonate that makes the carbon dioxide like lime water milky. Here لمدة طويلة الكربون دايوكسيد هيتفاعل مع الكالسيوم كربونات اللي هي بتطلع من الرياكشن بتاع الكربون دايوكسيد مع اللايم ووتر ويحولها تبقى كالسيوم بايكربونات. كالسيوم بايكربونات soluble in water so turbidity disappears. طيب دلوقتي هنتكلم على ايه؟ confirmatory test. To differentiate between the carbonate and the bicarbonate salt, we have to use the confirmatory test using magnesium sulfate solution. طبعا احنا اتفقنا ان هنا confirmatory test مش على السوليد سولت، على السولت solution. يبقى here white precipitate will be formed also magnesium carbonate but after heating as the following animation show. هنا we add magnesium sulfate solution on sodium bicarbonate solution, and we notice that no precipitate occur, but after heating now, as you show on the screen, white precipitate is formed. Here, why? Because the first is sodium bicarbonate reacts with magnesium carbonate. شوف دلوقتي المعادلة مع بعض اهي، ان الفيرست equation الصوديوم كربونات فاعل مع المغنيسيوم سلفيت، والثاني صوديوم سلفيت and magnesium bicarbonate. All bicarbonate soluble in water، يبقى no precipitate on cold. But after heating magnesium bicarbonate will be decomposed، هتتفكك، هتدينا magnesium carbonate solid precipitate ويطلع carbon dioxide gas and water. Now we are going to detect the sulfite anion. Here the main test, again the main test must be occur for the solid salt. So solid salt that containing the sulfite anion with dilute hydrochloric acid. What do you observe here? Here the observation is the evolution of colorless gas, which is SO2, which has irritating smell and turns paper wet with acidified potassium dichromate K2Cr2O7 from orange to green as the following animation show. هنا we add the dilute hydrochloric acid on the solid salt. We found that a gas produced. This gas has irritating smell, turns the paper that which is wet by acidified potassium dichromate from orange to green as shown on the screen. This is occur due to the production of sulfur dioxide gas. يبقى يا أساتذة هنشوف إن الصوديوم سلفايت reacts with hydrochloric acid. Here sodium sulfite is solid with aqueous hydrochloric acid. It gives what? Sodium chloride solution and sulfur dioxide gas. This sulfur dioxide gas has test with acidified potassium dichromate and water is produced. What is the test for sulfur dioxide gas? It turns paper wet by acidified potassium dichromate from orange to green. Here's the equation: potassium dichromate, which is acidified by H2SO4, reacts with sulfur dioxide gas. They give here potassium sulfate K2SO4 and chromium sulfate and water. Here potassium dichromate, as we know from chapter 1, it is oxidizing agent. So it oxidizes here the sulfur, and so the potassium dichromate, the chromium is reduced from positive 6 to positive 3, and the oxidation that happens turns the color of the potassium dichromate from orange to green as the chromium is reduced. The confirmatory test for the sulfite anion. Here we have to use what? The salt solution. Any confirmatory test, the solution of the salt must be used. Here by adding silver nitrate solution. What happens? It gives white precipitate of silver sulfite. This white precipitate turns black by heating as the following animation. As shown on the screen, we use here the solid salt and adding distilled water over it to make solution. Then we are going to add the silver nitrate solution for it. What do we observe? Here we observe white precipitate is formed in the test tube. We are going to heat it in the benzene flame. What are going to observe? Yes, it turns into black. This black precipitate here indicating that the salt is sulfite. So the equation sodium sulfite plus silver nitrate gives sodium nitrate and silver sulfite precipitate. My dear students, I hope you understood all that I explained today about the tests and the identification of anions, and we are going to continue our discussion on the rest of detection of anions in the next episode. So till we meet again, my best wishes for you.